Let's do one last difference quotient that's a little bit tricky again because it's got fractions. Everybody's favorite, right? So let's take a look at the difference quotient first, which is f of x plus h minus f of x all over h. So we'll start off, like we always have been, with these we're going to leave the h on the bottom. We're going to start out with looking at what does f of x plus h mean. Well, it means that we're going to replace any x's with an x plus h. So we're going to start out with a little fraction. The x that's on the bottom of it is going to get replaced with that x plus h. Again, you can go ahead and put parentheses around it. And then notice what's also down there is a plus 2. Then we can carry over our minus sign. And then we've also got to plug in our regular f of x function, which is just the original function unchanged, which is, if we take a look at the original function, a 1 over x plus 2. Okay, this again is kind of very similar to what was going on with the square roots. It's just super messy. It looks awful. The actual plugging things in wasn't too bad. It's just a question of what to do. And just like the square roots, whenever you see crazy fractions like this, we're going to handle it the exact same way every single time. Well, what we're going to do is, let's first rewrite it. 1 over x plus h was on the bottom, plus 2 of the first fraction, minus a 1 over x plus 2 on the second fraction, and then we've got another big fraction with this is all over h. What we're going to do with these two fractions is we want to get a common denominator so that we can bring these two pieces. The goal is to bring these two pieces together. Well, what's going to be your common denominator is, because both denominators are completely different, is we need to actually have both pieces in the common denominator. So we're going to use a common denominator, an LCD of both, of the x plus h plus 2 and the x plus 2. We actually need both. So how do we do that? Well, the way that we're going to do that is the first fraction already has the x plus h. It's missing the x plus 2. So what we're going to do is we're going to multiply the bottom by the x plus 2 so that it ends up having it. But then I've got to multiply the top by the x plus 2. Now we have to take a look at the second fraction and kind of do the same thing. Let's take a look. The second fraction, let's see. Second fraction, let's pick a different color. The second fraction already has the x plus 2. It's missing the other guy, the x plus h plus 2. So we're going to multiply its denominator by the x plus h plus 2. But just like the last one, if we multiply the bottom by something, I also have to multiply the top by something, the x plus h plus 2 as well. Okay. So now I have both on both fractions denominators. So they have a common denominator. So let's rewrite this because this looks a little bit messy. So let's carry this down. I should have my common denominator now. I do have that big h on the bottom. Now, so on top of my first fraction, I had a 1 and an x plus 2. Now I've got the common denominator of x plus h plus 2 and the x plus 2. Just rewriting that first fraction completely. Just taking that fraction and rewriting it so we can figure out what's going on. Just rewriting it. Now that we have a common denominator. Minus. Now let's write out our second piece and make sure that we've got everything. Our second piece was this guy. He already has the x plus 2 also, and the x plus h plus 2. And he had a 1 and the x plus h plus 2 on top. So that was our second piece. Okay. And it looks messy, like I said, but notice this. the x plus h plus 2 is on the first one and on the second one, so they do have a common denominator. And that's what really matters, because once you have a common denominator, you can bring two fractions together. So I'm going to leave my big H on the bottom, and we're going to bring together our two fractions with a common denominator of x plus h plus 2 and the x plus 2. They have a common denominator, so we can go ahead and bring them all together. However, I need to know what's on top of my first fraction and what's on the top of the second fraction. Let's see. Well, on the first fraction, we have a 1 times the x plus 2, which is just x plus 2. On the second fraction, we need to be a little bit careful, because it's not just a 1. It's a negative 1 that we're multiplying out to everything there. So it actually is going to give us a negative x, a negative h, and a negative 2. But at least it's one big fraction now, because they had a common denominator that we were able to get. One piece at a time still. Well, notice now we have an x and a minus x. So what will they do? They'll go ahead and cancel. What also do we have? We also have a plus 2 and a minus 2. So those are identical by opposite signs, so those will cancel out as well. And we are getting there. So let's see, what do we have left? Well, notice on top of my big fraction up on top, we still have the negative h on top, so there is still something there. We do have the common denominator of x plus h plus 2 and the x plus 2. And don't forget, this whole thing was still supposing to get divided. This whole thing is still supposed to get divided by an h. So this still looks pretty messy, but we are getting somewhere. Well, to kind of finalize this, I'm going to write this a little bit different. Remembering is that we're dividing by h. Well, remember that dividing by something is the same thing as multiplying by its reciprocal. So I'm going to leave the first fraction on top alone, the negative h over x plus h plus 2, and it's x plus 2. That top fraction is going to stay the same. But remember that dividing by something, like we are here, is the same thing as multiplying by its reciprocal. What does reciprocal mean? Reciprocal means take it and flip it upside down. Well, we've got an h here, which is just h over 1. So if you flip it upside down and take its reciprocal, you're actually going to get 1 over h. Why is that so important? Well, the reason why now is because we have a solo h on top that's by itself and a solo h on the bottom that's by itself. That means they can cancel out. And so the question is, what does that leave me with? Well, now I'm left with on top a negative and a 1. So I'm left with a negative 1 on top. And I still have my messy pieces on the bottom, the x plus h plus 2 and the x plus 2. But just like the square root problem, I don't have any solo h's by themselves. And it is okay to, at some point, if I needed to, plug in 0 for h, because if I did, I would just get an x plus 2 times an x plus 2. So this is absolutely perfect. As long as my solo h, which was down here, and here it is there, it got canceled out at some point, that's all that matters. So our final answer is this negative 1 over x plus h plus 2 times x plus 2. And that is our final answer for our simplified difference quotient.